So the programs DC Soil that you see on the left side here, they store the data in a database format of Microsoft Access. And that means that any project file can contain any number of tests or borehole logs or plans or whatever. And all changes are stored immediately in the database. So we start with DCBORE for the display of borehole logs or bore profiles. And first create a project file. And the program asks for the parameters of the first bore profile. So this could be a name like B1. We can define the application height, which might be a height over sea level, for example. We can define the coordinates. This may be Gauss-Krüger, Scout cylinder, and so on, different types like UTM. And these coordinates are used as well in DC section, as we see later. So for example, Gauss-Krüger, these are 7-digit numbers. Giving a position in the real world where the boring or the borehole log is located. What you see down here is data, especially for borehole ML. We have a new export format, which is used by the regional authorities to deliver the bore profiles from the boring company to the authorities, which store them all together. So we have a window divided in two panels. At the left side, we have the input of the main data, which is the information about the subsoil, the different soil layers. And at the right, we have an immediate control about the graphics to see if this is okay, what we entered on the left side. So for the soil layers, we first have the depth of the bottom for one layer. And then we can enter abbreviations and receive the long text automatically. This means we can use the short names, or we can enter any arbitrary text or add additional text here in the long text description. And how does the program know this? We have a symbol editor created for the program, which defines the abbreviations, the long texts, and also the display with symbols and with colors. So if you see, if we go to the next soil layer, the first one with gravel is displayed here with a color of yellow. And this is defined under settings, symbol editor. And you see here all the definitions for the soil types. And additional types may be added here as you need them. So for example, if we look at the gravel here, double click, we see that here we have a color of yellow for gravel. We have these symbols, and in this case, these are the symbols for British Standard 5930, for example. We have different symbol editor files for different standards. For German, DIN 4023, for Swiss standard, for Austrian standard, for British standard, and so on. And this symbol editor file may be changed in the configuration directory to support any standard that you will need. So the program knows that uppercase G means gravel, and for example, FS means fine sandy, if it's not the main soil type. So if we enter FS here, this is gravel, fine sandy, for example. We have additional nodes. We can define the consistency. We can enter the color, dark brown, for example, soil group, soil class, And there is a special edition for heat extraction, which can be defined and determined from the soil parameters for heat extraction constructions. Now we can define different soil layers. We might have clay, sand, and so on. And you see immediately how this is displayed in the graphics. And if you see any error in the input, you may just double-click the special soil layer, and the input window automatically jumps to this soil layer, where we can enter any correction or addition, and everything that is written here will be shown in the graphics. This is the most important type of input, and in addition to the soil types and soil layer depths, we have probes and water levels, which means probes, for example, which are taken from the bored soil. There might be at a depth of 0.8, for example, so-called special probe, and in 3 meters and 10 disturbed probe, and at a depth of 4 meters and 80. We might have a water probe, and these probes may get a name. For example, special probe 1, and the disturbed probe 1. And this is immediately, this was delete, sorry. This is immediately shown here in the input and in the output window. And at the same position here, we can define water levels. And this may be, for example, a groundwater level which is changing. We have, for example, bored at 2 meters and 50, groundwater bored, little date and time. And if the groundwater is changing, for example, this would be this would rise until 0.9 meters, change of water level. Then this is shown with an arrow here to show the rise of the water level. And there may be several different water levels. For example, this one was the first changed water level and the first bored groundwater. And if we find the second water level, for example, at 520, this is groundwater bored. And this is rising to a depth of 3 meters and 60. Change of water levels. And we have to define a number to show which water levels should be connected with an arrow. So with 3 meters and 60, this is water level 2, and 520 is again water level 2. And then we have 2 different arrows here showing different water levels with a rising level of the groundwater. And the program automatically keeps the space here for the description, and you see the level of this probe, and this is shifted a little bit to make all this description here available in this area of display. If there's not enough space, we can also change the scale. So under settings scale, for example, we can go to a depth scale of 1 to 50, And then we have more space here for display of all these parameters. There's a large extent of different configurations, what to show and how to display all these parameters. And you find this under settings configuration or under this icon here, this configuration icon. If we go to the page presentation, we can define that we also display consistency and color, for example. Then we have the color here. Or if there is not much space, we have many different soil layers in a very small depth. We can switch off the long text, for example. So we have only the abbreviations here to define the soil layers. In addition to this display of the borehole log, we have different forms. These are following different German standards. So there's DIN 4022, and there is the European standard DIN 22475, where we have a form with all these parameters included. And now we have two options to make the input for these forms. First, we enter the data here for the graphics. And then we can just jump to the layer specification for this special soil layer. And we have all the informations already filled in, which are defined for the graphics. And we can add here additional remarks. Like that's here. Or for example, hard to bore, different descriptions of the drilling process and so on. For these parameters or for these fields, we can define predefined text which come again and again, so we don't have to write it again anytime. So we can select this text, and with the right mouse button we can add this text to our menu. And here, for example, dark brown can be added, and you see that many texts are already predefined here. So if we close this window and go to the next soil layer, we have the clay here, and we can again switch to the layer specification. And here with the right mouse button, we have hard to bore in our menu and can select this text. The same with the color, for example here black. And this menu changes according to the kind of field that we have here. Here we have only the colors in the menu. Here we have the descriptions of the drilling process and so on. This is one option to make the input for any special soil layer immediately, or you enter all the soil layers at once and then switch to the layer specification as a whole. So we have an icon here. You see a little borehole log and a little form here. This is to switch between the bore profile input and the form input. And here you see the complete form, which is defined in ISO 14688, again with all these informations that we just entered in the dialog. And we can just switch through this form and add any data that we might need here. Here again, hard to bore, for example. And all the probes, water levels, and so on are filled automatically from the input window to this form. So this is the information about the borehole log. And there are several extensions for the program. For example, we have one extension for SPTs, for the borehole probings, and I will switch to a predefined project to have all the data available. For example, if here a much longer bore profile, and there is one profile, for example, with SPT tests, where we can define at any depth the number of blows which were tested, and we have automatically the number of blows per 45 centimeters, and this is displayed as bars in this diagram. And these bars may be filled or not filled, depending on the type of the cone which is used. In addition to the borehole log, we also can define the display of wells and piezometers, for example. And this is under this icon, you find all the input for gauge, wells, and measuring points. And there are different types of input. First, the head formation, which means we may have a concrete base, we have a concrete collar, a steel tube, a line cap, hydrant cap, and steel wellhead. And we can also have well casings, which are quite complex with different measures here, the height, width, the wall thickness, and so on, which can define in detail for the head of this well, for example. Second one is to define the tubes. So such a kind of pipes. And this may be several tubes, one beneath each other. We have the position of the tube as a distance from the bore axis, the height above surface, a depth of the water level, a pump symbol, and the head of this tube may be free or this kind of cap, absorb well, or fire extinguisher elbow. At the base of the pipe can be a base cap or a sounding cone, which connects two pipes together. And for one well type, one tube, we can have different sections. For example, if I click here, we can define that we have a top tube until 2.50 meters, for example, with a certain diameter. We can have different filter tubes, different displays of filter tubes, and a bottom tube, cementation items, packers, inner tube sleeve, and so on. And I will show an example to have not so much of input here. If we go to a different bore profile, here we define the complete well construction. And you see, if we go to the input here, that we have a well casing over ground at this height, and we have a concrete base and a steel tube connected here at the top of the well. And then we have these different tubes here. Tube number 1 is the left one with a negative distance from the bore axis, and tube number 2 is the right one at the right side. And you see the different types of tubes here, a top tube until 11 meters, filtering tube going to 70 meters, and the bottom tube to 20 meters. The pump is here defined at 1650, and the water level at rest is at 1150 here. In addition to these pipes, we have the infillings here. That means that there may be a clay, drill products, filter gravel, fine gravel, and so on. And again, we have different numbers. That means for number 1, with different sections and different depths, this is the inner filling, and number 2 is the outer filling. You see here that this is changing from gravel to sand, for example. And all these parameters are defined as well in the symbol editor. That means if we make a new section here, we can select bentonites, cement, clay, drill products, fine gravel, and so on, different types of fillings. And they may also be displayed in different ways. This can be a thick line for a stop tube, infill basket, a drawn tube, flush boring, infill pipe, and so on, with different displays at the edge of these fillings here. These are the main components of a well construction, and we have additional functions here for spacers, for example. You see here this spacers like a half a circle. Here these may be different types of graphics. For example, if we go here only on to 10 meters, and from 10 meters to 21, for every 1 meter, we have this wedge, for example, this type. Then we have these different spacers here displayed over the different depths. Labeling can be done for any type and is predefined automatically if it is not switched off. So labeling at the right side, for example, predefines the types that we entered for any tube, for any filling, for the water level, and so on. This is defined here automatically. You can add additional texts for the description. And the program automatically knows that this description top tube is connected to tube number 1 to 4 meters and 20, so in half of the depth. And if this tube is changing, if we enter a different depth here, for example, this description is automatically linked to this tube and is going to a different depth to have always the center of any area which is defined here. And finally, we have a vertical labeling here. For example, this label, which is displayed here vertically. So far to the well construction. And finally, we have one more information in the symbol editor, which may be defined. This is for the special heat extraction constructions, which is an additional option for the program. So for example, how many watt per meter depth can be taken from the ground for heat extraction. This is different for certain annual performance of 1,800 hours or 2,400 hours per year, and is distinguished between above groundwater and below groundwater. Now, for example, we have 20 above and 50 below groundwater. And if we define this for sand as well, and this option for 1,800 or 2,400 is defined with the basic parameters of this bore profile. So we have a heat extraction per year of 1,800 hours, for example. And if we have defined this may be displayed in the graphics as well. If it is selected in the configuration. Here on the presentation, we can add the heat extraction for the soil layers. So the program automatically calculates the possible heat extraction per soil layer with a different type and gives a total value of 899 watt. And this may as well print it in a special table. Here on the bore profile table heat extraction. This is calculated for any soil layer and may be printed as a separate page here in this form of a table. This is a special option, DCBORE heat extraction for the program. One option for heat extraction constructions, which is contained automatically by default in DCBORE, is to display the tubes correspondingly. This means if we have the same depth, here we have 20 meters, for example, and the tube number 1 could go as well down to 20 meters and gets a sounding cone at the end. Then this is connecting the both pipes. And now we can define under settings colors that the filling of the tube number 1 is blue, for example, and the filling of tube number 2 is red. And now we see automatically we have cold water here, warm water here, getting out from the soil for this heat extraction construction. And these both tubes are connected here by this base cap or sounding cone.